Understanding Materials Lecture 3 by Lee Burton. In Lecture 2 we learned about the y-axis of band diagrams and how states are full up to E minus EF is 0. This time let's look at the symbols on the x-axis. To do so, let's return to our atomic model of materials. Specifically, a unit cell that is mirrored to infinity has an electron density profile that is wave-like. Infinite electron density is easier to treat as a frequency. For example, this wave has a frequency of 2 cycles for one unit cell. Each frequency will have a corresponding energy. It's possible to have a zero-frequency electron wave corresponding to all orbitals in phase, or any number frequency in fact. The energies depend on the atoms in the unit cell, so the energies usually aren't the same. When we move to a frequency plot, the units become inverse or reciprocal distance. One unit cell has a real distance, usually expressed in nanometers, and we change to waves per distance, therefore the distance is inverted or reciprocal. So far, we have looked at electron waves in one dimension. But we are trying to understand three-dimensional unit cells. Let's add a dimension to consider a plane wave. A wave in 2 dimensions is like a ripple on the surface of water. Plane waves can also be described with frequencies. A frequency plot will also need an extra dimension. This wave has a frequency of 4 in x direction and a frequency of 2 in the y direction. So its energy can be recorded at the 4, 2 position. We see that frequency can act as grid coordinates for an energy landscape. But this is still 1 dimension short of the 3-dimensional treatment we need. Real electron density in a unit cell is 3-dimensional. Some areas have high density and some have low density, but always repeated infinitely by symmetry operating on the unit cell. So we need a 3rd dimension of frequencies too. Changing from a grid of frequency coordinates to a geometric shape of frequency coordinates. In Lecture 4, we will see how this relates to band structures. and how all of this helps us understand materials. Understanding materials, end of lecture 3.